Time for another scientific literacy lesson. This will be the first video in a three-part series about quantum computers. Unless you've been living under a rock, you've probably heard the term quantum computers before, but the whole concept is a little bit esoteric. I'd like to share a non-expert enthusiast's introduction to quantum computing, but before we can talk about quantum computing in a meaningful way, we've got to understand traditional computers. Computers are just information manipulation devices. They take information and then they do something with it. What type of information they manipulate and what they do with it can vary widely. A common misconception is that all computers are electronic. The reality is computers can be made of just about anything that allows them to store and manipulate information. The earliest computers, or devices that could be compared to computers, were purely mechanical. What I mean by that is they had moving parts instead of electronics. For example, this was a computer. It's called a mechanical computer. It's made of levers and gears. There are no electronic components. This is also a computer, and so is this. The idea of the computer evolved to incorporate electronic components like vacuum tubes and eventually the transistors that we still use today. Computers that use electronic components like transistors we refer to as digital computers. Modern digital computers can do a variety of different functions with information because we can alter the way they manipulate information. It's also known as being programmable. That's why you're able to run so many different programs and softwares on your computer and on your smartphone. They're built in a way that allows us to alter what they do with information. There are many components of modern digital computers, but the four central components would be the control unit, the arithmetic logic unit, the input-output devices, and the memory. The control unit is like the boss. It reads instructions from programs, lines of code, and it translates that into what the computer should be doing, and it tells the other components what to do. The arithmetic logic unit is kind of like the onboard calculator. So it performs some basic mathematical functions and it also handles some specific types of instructions like conditional statements. The input-output devices are just how the computer communicates with the world. So your keyboard, your mouse pad, your touch screen are all input devices that tell the computer something, give it new information. And then things like the monitor, the view screen, the printer are output devices where the computer communicates outward. Finally, the memory is kind of like a workbench. It stores information temporarily while it's being accessed or manipulated by the control unit, the arithmetic logic unit. You've probably heard stories or anecdotes about how older computers could be as large as a room, had enormous energy costs, and could still only perform basic functions, whereas the computer that's in your smartphone today is thousands of times more powerful at a fraction the energy cost and size, which is true. All computers are limited by the capacity of their processors to process and manipulate information and their memory to temporarily store that information. Over many decades, there have been several advancements in the size and type of materials used, the actual mechanisms that do the processing, the processes that they follow to manipulate information, and each of these has a significant impact on the size and the power of the computer. That's as good a place as any to start part one. In part two, I'm going to talk a little bit more about where quantum computers get their name from. That's quantum mechanics.